My name is Iyab Mariam, and I would like to begin by thanking everyone for joining us on another session of Power Hour. My co-host for today's session is Sean Ryan, who's another senior sales engineer with NovaTech. During this Power Hour, we'll be covering the configuration of an Orion substation RTU from the start to the finish. And prior to beginning, I would like to preface prior to starting the session by mentioning that we'll be covering a number of different applications within the Orion with a reasonable amount of explanation, but due to our time constraint. In-depth explanations of each of these applications that we'll be covering have already been covered in prior Power Hours, and those videos can be found on the NovaTech Power Community website. Our topics for today consist of creating a configuration file for our substation RTU in a cascaded fashion. We'll talk about what cascading entails shortly. Next, Sean Ryan will jump in and create some master protocols, some master ports to communicate to SMSCL 351s that we have connected serially. He'll also set up a DNP master port over TCP IP to talk to a Bitronics SCADA panel meter. I'll jump back in and work on the configuration of the Orion I/O and add in configuration of captions and aliasing to further define those statuses. Next, we'll configure a DNP slave port to talk to our SCADA master. And then to finish off the configuration side of things, we'll cover 3 different applications. The first application is going to be LogicPak. So we'll do some logic operations using that function. Next, we'll configure what we refer to as alarm archiving and retentive. So to have a local historian at the substation level. Lastly, we'll design a one-line for our substation and make sure to kind of go through the steps of how to set that screen up. To finish off the session today, we will go into the web interface of the Orion, load our configuration file, make sure our devices are communicating, and make sure our data values are coming in, and do some testing for our one-line screens. This is going to be our system to be configured today. So we have a physical RTU that we're going to be connecting to, and we have at the top end. Notice that we have a simulated SCADA master already configured, waiting for the RTU to send it data. So we'll make sure to set up our DNP slave port there on our Orion LX Plus RTU. The serial connections that we have to our RTU are going to be 2 SCL 351 devices on ports 3 and 4. We also have a switch connected to ETH0 on the Orion LX Plus RTU. On that switch, we have our SCADA panel meter as well as our Orion I/O. So we will be referring back to this diagram to make sure that we have all the different aspects configured for this RTU. In addition to this layout diagram, I've put together a points list that we could refer to for reference as well, as we're setting up our master ports. If we wanted to look at addressing, scaling, point descriptions. So this points list is kind of a concise points list that will assist us with that portion there. With that said, I'm going to jump right into our configuration tool, which is called NCD. I'm going to go ahead and launch the NCD software. And the first thing we're going to do is build our configuration file from scratch. So we're going to go ahead and create a brand new config file. So we're going to go to File, and we'll go ahead and create a new configuration file. The first thing NCD is going to ask us to do is pick the platform that we're configuring. In this instance, we have an Orion LX Plus as our substation RTU. So we want to make sure that's selected. The other selection that we're going to make is going to be this selection here where it says Cascaded NCD file. All right. So what this is referring to is if we look back at our diagram, we have two Orions here. We have the Orion LX Plus RTU and we have our Orion IO. One of the applications that we have with the Orion product lines is called cascading. And the benefit, it's got actually a number of benefits, but one of the main benefits that it has is that you could have one configuration file for your multiple different Orion products. So in this case, we could have one configuration for our Orion LX Plus RTU, and we could have one, the same configuration can be used for this Orion IO as well. And we'll dive a little bit deeper into that as we go further. To start, so we're going to go ahead and select our Orion LX Plus RTU as a model for configuration today. And then we're going to also checkbox the Cascaded NCD file option. And I'm going to hit OK. As soon as I do that, with the Cascaded configuration file, the first thing it's going to ask you is, since it's a network-based application, what is the IP address of your RTU? And if we look in our diagram, our IP address for our Orion LX Plus RTU is at 172.16.68.141. So we're going to make sure that's specified. 172.16.68.141. Aside from that, the TCP port address for cascading is 5001. That does not need to be changed. We do have options for security with cascading. We are going to disable that at this point. All right. Now we're going to hit done, and we are ready to start building our configuration file. Under configure, go ahead, Sean. Sean will go ahead and...
I think it's where I jump in.
Yep.
Good morning, everybody. Again, I'm Sean Ryan. We're going to be going through here. And as Eob prefaced already, this is going to be kind of more of an intermediate style power. We're not going to necessarily do a deep dive into every single little checkbox here and there, but we're going to show just how easy it can be, again, to build this as a real-world scenario, as we do have with actual physical devices here, but how we can just quickly build our connections. So as Eob showed on the diagram, we have two Schweitzer 351A relays, and we're going to be connecting to those through serial ports 3 and 4 here. So as Eob started, we're going to go to configure. Hopefully this is working. Cool. Serial ports, and then I'm going to start by going to port 3. Now just keep in mind that these ports here, ports 1 through 16, are physically correlated to the rear ports on the back of the LX Plus itself. So I do need to select the correct physical ports here. So I'm going to select port 3. The dialog box is going to pop up, and I'm going to go down and find my Schweitzer SEL protocol here, select OK. And then, again, as we said, we have the Schweitzer 351A relays, so I'm going to find those within my pick lists here. So I'm going to be scrolling down, and I'm going to not go too far as I did. Sorry, I'm working remotely actually through Eob's computer here. So I've got the 351A relay there, and I'm just going to click accept to start, and it's going to update this device, and it's going to minimize this. So now at this point, I'm going to go through, and I'm actually going to give a name to this particular device. You're noticing the description here propagates through, and that's going to follow through as I'm building my points lists. And so since we didn't have an official name for it, I'm just going to call this SEL 351. And then I'm going to give it an underscore, and I'm going to call it feeder 123. By default, the Schweitzer username and password here, or I should say the level 1 and level 2 passwords are in there, otter and tail. Eob, correct me if I'm wrong, but I believe that's how our relays are configured already. And then you'll see it's doing the relay protocol fast messaging, which is all good for us at this time. So I'm going to go ahead and click accept here, and that is enough to make our device unique here with the description. So keep this in mind. We're going to refer back to this later. But at this point, I'm going to go over to my inputs, and I'm going to start grabbing the stuff that I want to pull my relay for. Now, to some degree, it wouldn't necessarily be wrong to just select all of these points and bring them over to the right. That would bring a lot of data into the Orion, and then we can pick and choose as we build our slave ports later. But at this point, I'm just going to do what's going to be some of the baseline or common points here. So by holding Shift and Control and some of the keys, you can actually select which points you want all at once. So I'm going to grab all of my currents here like this. I'm going to go ahead and grab the individual phase voltages. I'm going to go ahead and grab my megawatts here. I'm going to grab my megavars. I'm going to send all those over because those are what I can see already. And you'll notice that, again, they've got the scaling in there already for me. Now, I also want my frequency, and so I could be scrolling through this list if I want to, but I can do some shortcuts here, and I can filter by partial text, grab my meter frequency, and throw that over. And that might be some of the, again, the basic power parameters that I want to include for my relay. Now, I'm going to find some of the discretes here. You'll notice as soon as I switch back to discrete, I've got nothing because my search bar is still populated. So I'm going to go ahead and clear that search out, and it's going to come up with all of these points here now. Again, all of the points that are available in the relay by default. So I'm going to go ahead and grab some of these to begin with. I went too far, so I'm just going to hold Control and click it again to remove that. Send them over to the right, and those are the points that I want at this time. And then I also want to grab a 52A point. And so again, I can search by that partial text and find it. Your specific application might vary because, again, some customers are monitoring the actual input contacts on relays that are hardwired to breaker statuses, etc. And you'll need to, of course, pick those as appropriately. But at this point, by returning to all points, I now have some of my analogs selected, some of my discretes selected. And at this time, if I go to outputs, if I wanted to grab some of these at the relay, that's where I would do so. But we're actually just going to pull this relay for information, and we're not going to actually be sending any controls down to this particular one. We're going to save that for the Orion I/O later. But that is a quick configuration of how I can get these data points from that particular Schweitzer 351 relay. So again, this is serial port 3. At this point, I am complete with this device. Now, the benefits to NCD really start to show themselves when it comes to the replication of devices. I'm going to make the probably easy assumption that a good number of your feeder relays are configured all the same. They have the exact same communication points or SCADA points that you want to pull back from it. The only thing that's really going to vary between your multiple feeders from a communications perspective is the name and then potentially some of the addressing from one relay to the next, perhaps usernames and passwords, etc., on the Schweitzer protocol. But again, all of these points and their parameters are going to stay the same from one device to the next. So what I can do is in here, I can, if I had a 485 string and such, I could actually duplicate the device internally. But what I want to do is I actually want to copy the entire port itself because we had serial ports 3 and 4 selected. So what I'm going to do is I'm going to click a copy port, and it's going to bring up a dialog box asking me which of the available ports I actually want to duplicate or replicate this device on. And so since we're on 3, it's not there, I'm going to select 4, and we're going to press OK. And when I do that, another dialog box is going to pop up. And you'll notice the port name is still SEL client. It's quite generic. It's actually some of the defaults here. But when we go back to the device, all we need to do is change some of the unique parameters from one to the next. Now, one step that I did skip, and I'm going to go back to it real quickly, is I'm going to go to my serial ports, and I actually covered the device portion, but I did not configure the port itself. So if we go back to the port settings now, one feature that we do want to highlight is typically your 8.1 none is fine by default, but I skipped the baud rate parameter. And so you'll want to configure that appropriately to your relay. But if you don't know the baud, which in my case I don't, I'm actually going to select the auto baud, and the Orion is actually going to interrogate that relay and try to get a baud match. And when it does so, the Orion will automatically set that port setting to the discovered baud rate when the communications start to work between the Orion and the downstream device. So we can go ahead and do that, click accept, and now we have, again, that device completely configured. So if I close this port, it's going to take me right back to port 4, and I can do the same thing. Port, I can change my baud rate, again, back to auto baud. But you'll notice that when I made my mistake, it's keeping every setting that I took when I copied the ports from one to another, except, as I mentioned, those unique per device names. So in this case, I'm going to go back and change the description. I'm going to call it a Schweitzer. Let's not do that. Let's do 351. And then I'm going to do something along those lines. And again, click accept, update yes. And at this point, I'm done, because when I go into my inputs, because I copied that port, all of the inputs and outputs that I selected are already replicated in there. So just that quick, again, by changing those unique parameters, such as the name and, again, any of the potential passwords in here that might vary from one device to the next, I can quickly replicate one device into many and save quite a bit of time by doing so. Yeah, but if I got anything, please feel free to interrupt me there. But otherwise, I'm going to jump into how to create a DNP master port for one of our Bitronics meters. So to get out of here, I'm just going to go ahead and close the port. And it's going to take us back to a baseline. I'm going to go to Configure, go down to Network, and now we're going to do Configure New Port. I'm going to select this. And then again, I'm going to pick the protocol that I want to use. So in this case, DNP client, so that way I can interrogate my Bitronics meter. I'm going to press OK. And now I'm going to go through some of the port parameters on here. Now, we have actually, I'll say, pre-configured our Bitronics meter or left it at the default values. So what we're doing here is we've got the port name and the client address. This is the DNP address that the Orion LX Plus is going to present itself as to the Bitronics meter. So in this case, we're just going to leave this as the default. And then down here in the IP options, we actually need to put the IP address of that D650 that we have based off of the map that Eob showed prior. So in this case, it's going to be 172.16.68.143. And then the most of the time, 99% of the time, all of these parameters are going to be fine by default. I could change the port name if I wanted to, but at this time I'm going to click accept. And then I'm going to go into add new device, and we're going to use our pick lists again in the same fashion that we did with our Schweitzer relay. So we're going to come down, we're going to find Bitronics, we're going to find that M650 relay, or meter, panel meter, and I like to just click accept right away, and that way it shrinks that screen up and I see all of my device parameters presented here. So changing the description, I'm going to make it a little bit more unique. I'm going to call it my M650, and I'll just call it meter, like so. I need to enter the DNP address of the meter itself, which defaults to 1, just happens to be 1. So I'm actually going to leave this because this is our correct parameter, but you will need to change that if needed. And then coming down, a good majority of the time, this was going to work just as is. Now, one thing I'll point out is we're just going to be using 16-bit values, but if you were to be configuring something that had 32-bit counters or analogs, etc., you'd go ahead and enable this smart reading, and then you could select these if you wanted to grab those types of points. But in our case, we're just going to keep things basic and let it work this way. So again, I'm just going to click accept because it's going to apply that description for me. I'm going to click yes, and now we're able to go into our inputs. Now here, again, whatever is available in that device is on the left, and whatever I want to pull for, I'm just going to go ahead and bring over to the right side. So I'm just going to start off by grabbing a good bit of this stuff that I want. And if I go too far, again, I can hold control, click one, and send these values over. So that's going to give me my amps, my volts, my watts and vars total, break it down by individual phases here, and a few extra little points, but then give me my neutral current and my frequency. And I mean, obviously I could grab a few more points if I wanted to, but we're going to go ahead and let this be for the time. You'll notice as you go through here, again, there's several more points that are available in that meter if they want to be used. And again, we can still search by that partial text up above to help us find the specific points that we want to actually include in our list over here that the LX Plus will pull that meter for. So with that, I believe we are complete on the meter side. And I think we're going to throw it back over to Eob, and he's going to configure an Orion I/O.
Thank you, Sean. So yeah, that was perfectly fine there, Sean. The next thing we want to do, so as you guys could see, at this point, we have our Orion LX Plus RTU. We've created a cascaded in configuration file. So we'll talk about that in a second. Sean has just configured two of the SCL 351s on ports 3 and 4. That's where he copied port 3 to port 4 so that he didn't have to redo that work again. He's also configured the Bitronics meter that's on the same network at address 172.16.68.143. So in terms of configuring devices, what we have left is going to be configuring our Orion I/O. Notice the IP address 172.68.142 to be on the same network there. And then we also have to configure our simulated SCADA master. Again, the SCADA master is sitting there waiting for it to receive data from the LX Plus. So with that said, let's go into the configuration of the Orion I/O. Like I've mentioned, we are using cascading for the configuration of the Orion LX Plus and the Orion I/O. So that means that we could create the configuration of the Orion I/O right here within this Orion LX Plus RTU configuration file. And so you guys could see here, this is where Sean did most of his work in terms of adding the serial connections and adding the network connections. But when it comes to cascading, what you'll have is you'll have an option for adding additional servers. Again, these are going to be additional Orion's products, whether it's an Orion LX, Orion LX M, Orion I/O, and so on. So we're going to go ahead and add a server. And as soon as we add the server, it's going to say which model is that other Orion platform. So in this case, we have an Orion I/O that we're going to be configuring. So we'll say Orion I/O. Well, you do have an advanced user interface on this Orion I/O. All that means is it's got that 4x20 character LED display on the front of it. And then we do have an Ethernet switch option on the Orion I/Os. I don't have it on this particular Orion I/O, so I'm going to leave that unchecked. With that said, I'm going to hit OK. As soon as I hit OK, like I mentioned earlier, cascading is a network-based protocol. So earlier we gave it the RTU's IP address. Now we're giving it the Orion I/O's IP address. We could even give it then a different name as well. So instead of server 1, we could call it I/O 1. And then we want to make sure we specify our IP address for this I/O device. 7.2.16.68.142. So again, notice the TCP port address for cascading is still the same, 5001. That does not need to be changed. Notice since that we had disabled security initially with when we created this cascaded NCD file, it's also by default disabled here for you as well. Now that I've done that, I'm going to hit done. And when I go back to my configure tab, notice I have my other Orion device ready to be configured. All right, with that said, The first thing really on the Orion I/O, it's designed to be a high density I/O module. So it's got 4 different card slots on the back of that Orion I/O. It's got card slots A, B, C, and D. And any one of those slots could be one of 7 different types of cards, whether it's a discrete input card, discrete output card, or an analog input card. So the first thing we're going to do with this Orion I/O is really not configure serial ports or network. We're going to go to hardware I/O and define those I/O cards. So we're going to go to I/O cards here. And now that we're in I/O cards, notice here we're on the port tab in this navigation area on the left. And notice we're on the port tab. There's really not much you do there. The only thing that the first thing I'm going to do is select on add new card right over here on the left-hand side. I'm going to hit add new card. Notice that it adds a card A for me. Again, like I mentioned, there's 4 different cards on the Orion I/O. So I'm going to proceed to add a second card, card B, and then add my card C and add card D. So now that I have all 4 cards created, notice if I try to add a 5th card, it gives me a limit indication of 4. So now that I've added all my 4 cards, the first thing I'm going to do is go to card A. And I'm going to say, all right, I'm going to look on my back of my Orion I/O to see how it's been configured. And this particular Orion I/O that's in front of me has a discrete input card there that's wetted. So for that, I'm going to do 16DI wetted type 3. This is our standard card that comes by default. I'm going to hit accept, and then I'm going to move on to card B and define the card there. And card B, looking at my Orion I/O, is a 16 discrete output card. It's not the high power output, it's just a standard it's just a standard 16 discrete output card type 0. So I will make that selection there. I will proceed to defining my card C. So looking at my Orion I/O, I have an analog input card on card C and D. So I'm going to go ahead and select 8 analog inputs there. And then lastly, I'll define my card D by saying that it's also an 8 analog input card. All right, so that means that I have 16 discrete inputs, 16 discrete out, and 16 analog inputs in this one Orion I/O module. Now that we've defined the types of cards that we have on the Orion I/O, the next thing we need to define is the channels for each of those cards. So for that, I'm going to go to card A and I'm going to go to inputs. Notice before I go to inputs, I do have an option of selecting whether I want high wetting voltage or low wetting voltage. So that is a software selectable option on the Orion I/O. So I'm going to go to inputs. I'm going to assume my wetting voltage is going to be high, and I'm just going to go to inputs. And the first thing I'm going to do to configure my first card, card A, which has the 16 discrete input stat channels, is I'm going to map in the 16 input channels to the right side from my tag name list. So that's the first thing I'm going to do. Notice that I've just simply mapped 16 channels that are on that card to be read in by that config file. Next thing I'm going to do is go to, and we'll come back to the details of this, all these statuses in terms of the caption, the on message, off message, invert LED. We'll be right back to that. The next thing I'm going to do is go to card B. Again, my card B is a 16 discrete output card. So for that, I'm going to go to outputs, and I'm going to map in my 16 output card channels. So notice outputs 1 through 16. I've mapped those guys in there again. Lastly, we have cards C and D that are made up of the analog input card. So if I go to card C, notice it's an analog input card, so I'm going to go to inputs and make sure that I map in my 8 analog inputs that are available on card C. And card D, same concept. I have an analog input card there, so I'm going to go to inputs and make sure that I map in my 8 channels on that card. All right, so the next part of the configuration of the Orion I/O is really more detail oriented in terms of, so if I go, for example, to the card A, which is a 16 discrete input card, if I go to inputs, now we're more detail oriented in terms of what kind of captions do I want? What kind of off message, on message do I want? Do I want to invert the LED? Do I want the filter times to be different? So those kind of parameters is what I could dive into once I've got the once I've defined the card and I've mapped in the channels. Those are the kind of details that I'm going to have to iron out. in this case, under card A, under inputs, we've mapped in our channels. So one of the things you could do here is make sure your captions are reading correctly. So for that, for example, we have this offline Orion I/O simulation. So if I click on this little button here that says Show Orion I/O Preview Window, I could select that, and let me make that a little bigger. And so this kind of gives me a visual of my Orion I/O. What if I was to look at the front of the Orion I/O, what it would look like based on the configuration so far. With that said, if I look at card A, notice if I tap on card A, I see that it's got a binary input status name, and it's got an off-on message of off and on. All right, same thing with contact B on card A, contact 3 on card A as well. Notice that LEDs as well. I know it says green LEDs for my discrete inputs on the card A. Notice I have red LEDs for card B. Notice I have amber LEDs for card C and D. All right, with that in mind, I'm going to back up out of this offline simulation. And one of the things I wanted to do is I want to make sure that I have a point defined for my captions. So what I wanted to do, if I wanted to make sure these caption names are correctly defined, I could do a couple different things. I could assign what we call aliasing, which will give these channel names a description name. So what I could do is I could go to aliasing, Orion I/O aliasing. So under add-ons, I could come here and I could say I want to configure instead of doing that actually, instead of doing that, I'm actually going to go ahead and configure the captions. And yeah, I'm trying to think which way to do it. Okay, let's go ahead and do the captions first. So I'm going to go ahead and minimize my NCD to the left-hand side by doing this. So I have a couple options.
Hey, I think go into aliasing on the main device.
On the main RTU.
Yeah, okay. That's where the aliasing pops up.
So I was going to save that until later, but okay, we'll go ahead and do it. No, you're good. You're good. So we have a couple options. So we could do it on. So the first thing I could do is I could say, you know what, I want these captions, instead of saying binary input 1, binary input 2, binary input 3, I could go ahead and make sure these captions have names that actually mean something to me. So for that reason, what I could do is I could actually go back to my Excel spreadsheet, and I could go down to my points list and find where I have my Orion I/O statuses. So notice here, this is where I have my North Sub Orion I/O card A channels 1 through 16. And if I scroll to the right a little bit, I have my descriptions for those channels right over here. So one of the things I could do is I could say, all right, these are the descriptions for channels 1 through 16. I could drag and drop these right into NCD. And so those names from that Excel spreadsheet pop right in there. And so now when I open up my offline Orion I/O simulator, so let's open that up again. So now when I hit card A, card B, card C, those captions are already defined there. So this is if you're physically in front of the Orion I/O looking at that LED display and wanting to know what that first channel is wired to. You can see that description there, and you can also go ahead and define what kind of on and off messages that you have. So that's going to be one of the captions that you could deal with. The other side of that I wanted to touch on was aliasing. So on the aliasing side of things is basically in your configuration and your interface. Whenever you're connected to the web interface or terminal interface, there's a column that shows up that says aliasing, which essentially gives you a secondary description for each of those point names. So for that, all we're going to do is we're going to go to our RTU configuration. Under add-ons, we'll see that we have aliasing there. And so for that, I'm going to go ahead and enable that. And notice here on your left-hand side, we have all the different points that Sean has configured in the master port. So for example, the port 3 points that Sean configured earlier. We have the points that are on port 4. We also have the points that are available in the IIO, in the Orion I/O device. So again, these are the Orion I/O statuses. One of the other options for providing descriptions is that you could open up aliasing and make this a little smaller. I could take these points, these descriptions that I have, and I could drag and drop them right into the available list of alias names on the right-hand side. And once I've done that, I could say, you know what, I want my alias for this guy to be T1 cooling power fail, and so on and so on. You could drag it and choose to put it any of the points that you have available to you. All right, so I'm going to go ahead and finish this out real quick so that we have both the captions and our aliasing defined.
So I'm just going to jump in, and while Eob does that, some of the main advantages of this really comes down to some of the philosophy, too, of your design. But you'll notice that as he's going through here and putting the specific point types to the binary inputs, what this does is, A, it allows you to build template devices, if you will. So you can build several of these Orion IO or any other IEDs necessarily and keep those point names common like that, and then just add in the specific applications with the alias. And then the other portion, which is my personal favorite aspect or preference to this, is that it keeps the physical to the representation relationship in place, meaning now I know where these specific points are. So if I have a hot oil alarm for transformer 1, for example, I also know that that's physically located on binary input 3 there. So if I need to troubleshoot or look at the back of the box, I know exactly where those hardware points are from.
Yep. Thank you, Sean. That's perfect. So here, notice one thing you'll notice that once I finish configuring that alias port, notice now I have a new column in my configuration window that says alias. So again, this caption is actually what you see on the front of the Orion IO here if I'm at the front of it and looking at the display, that 4x20 character LED display. But what you're seeing here in the aliasing is going to be for your purposes in the configuration side of things, and then as well as whenever you're connected to the web interface, you'll have that alias column where you could see exactly what that point is defined as. So two different purposes, but they both help out a lot when you're looking at the full configuration of things. So let's go. So that's going to be all we're going to do there. Again, keep in mind I have an option of inverting the LEDs here on my Orion IO. Again, I'm going to keep those off so that if there's no wetting voltage on that contact, the LED is off. If there is wetting voltage, the LED is on. If I want to invert that where the LED stays on until there's a wetting voltage, I could essentially enable that there. And if I filter, if I go to the binary tab down below, notice that I have options for modifying things like my chatter time, my chatter count, my filter, my debounce, those kind of parameters, which is, again, more detail-oriented for those binary inputs. So, again, we're going to go to card B. Again, card B was our discrete output card, so we're going to go to outputs there. And notice there what we're going to be able to do is we could notice they have captions as well. So we're going to map in those captions from our points list. And I have them right below on card B. So we'll take these outputs and make sure we drag and drop them right. Let me make this a little smaller. Notice these little tools that I'm using. NCD allows you to kind of minimize certain windows so that you could, again, utilize this drop and drag tool. So I'm going to just drag and drop it. Notice you have to grab the corner of that Excel spreadsheet cell and then just drop it right into NCD. And so we'll get our captions populated there. So now that I'm done, the other thing that it shows me here for my outputs is the type of output that it is. Notice it starts with latch, and so you can modify the mode for each of these output channels. So the first one is going to be latch. The next one, let me make this a little bit smaller. So the next one is going to be a pulse. We have a latch in this configuration here. We have another latch here, and 3 latches. And we have a pulse. We have another 3 latches there. And then we have 1 pulse, and then 3 latches, and then finish it off there. And then pulse and then latch. All right, so we've defined the type of control these are going to be. We've also just gave them some captions so that we know what that's going to, what those outputs are going to be controlling. The other parameters that you see here are going to be time override. Because of outputs, because of the outputs are going to be dependent on hierarchy. So you have your SCADA master, you have your RTU. And so SCADA master could send you down an on time, or the Orion RTU could define the on time of that control as well. So for that instance, we could have, this little checkbox to override that time, where if it's overridden, then the Orion is going to define what the on time is. If it's not checked, then the SCADA is going to be expecting a time from the SCADA master. So in this case, we'll leave it the way it is. And so aside from that, when it comes to analog inputs on card C and D, all we want to make sure is that our transducer parameters are selected. Again, you have a negative 10 volts to 10 volts selection, or negative 2 to 2 milliamp, or 4 to 20 milliamp. So we're going to leave ours at negative 10 to 10 volts, so we'll leave the descriptions as they are at this point. So at this point, we've really truly configured both our SCL devices. We've configured our Bitronics device here. We've also configured our Orion I/O. All right. So when we take this file and we load it into the Orion RTU, it's going to send down the configuration file for the Orion I/O as well. We'll talk about how that happens in a little bit. But aside from that, what we want to do at this point is we want to set up a port to our SCADA master so that we could send data using DNP protocol. So we're going to go back to our RTU configuration. So we're back to our client, Orion client there, which is going to be our Orion LX Plus. Our SCADA master is connected via a TCP IP network. So we're going to go to network, and we're going to do configure new port. As soon as I do that, it gives me this dialog box, and it asks me what's the protocol that I want to use to communicate. So I'm going to say DNP server, because we're going to be serving data to our SCADA master. I'm going to hit OK. So here, very similar to the DNP window that Sean used, but again, this is going to be the server side versus the client. So you'll see some slight differences in parameters that you could configure. Under port, there's really not much we have to do here. Like Sean mentioned earlier, we're dealing with 32-bit counters, 32-bit analogs. We can modify these variations down below so that the RTU is sending 32-bit values. But aside from that, the only other thing that I would point out is that we have a location where we could define reservation IP addresses for our SCADA master and what other systems will be controlling or connecting to this port. In this case, we're going to leave that blank as well, and all we're going to do is we're going to do add new RTU.
One thing I do want to interrupt you, I'm sorry, I just want to point out the max connections field. It does default to 1, as you see there, but depending upon your particular application, let's say you have multiple SCADA masters, maybe you have a site A, a site B, maybe even a C. If those sites are simultaneously polling the Orion on that port 20,000, we'll actually need to bump up that number of max connections. If you want to limit the Orion to only have a single session so that it only listens to one SCADA master at a time, you can leave it at 1, but do keep that field in mind.
Yep. Good point there. So the next thing, so the only thing I'm going to do, since we only have one connection that we're dealing with at this point, we're going to go ahead and do add new RTU. So again, this is going to be called RTU1 as a description. That is just fine. You could also give it the substation name or call it SCADA. So the two big parameters that I want to point out here is going to be the RTU address that you see here. Again, that's going to be the RTU address, so we're going to make sure we're going to keep that at 1. And then we have our destination address, which is going to be the same thing as the client address in this case. I believe it's 2, so we'll leave that the way it is. I need to double check. I think that was. So aside from that, we're going to go ahead and add, we have other parameters here for the DNP server side, like, if we wanted to set up indication bits and make sure the RTU request time bit is sent, we can make sure that's enabled, or the trouble bit is sent. We have other parameters for unsolicited responses for different types of classes, so we could set up class 1 to enable unsolicited messages and so on. We could also set up each individual class to have events with time-stamped data. So we have a couple different other parameters that we could set up here, but in this case, we are just going to go to our inputs tab and map in our points. So if we only go to inputs, what you see here is going to be what we refer to as Orion real-time database. So this is essentially all the points that we've configured so far. All the points coming from that SCL device, all the points coming from the Bitronics meters, all the points coming from the Orion IO, and then also some internal indication statuses. Again, since this list has a tendency to get large, notice that's already getting pretty large here. Since this list has a tendency to get large, one of the tools I like to make sure is the filtering tool. So this little drop-down arrow lets you pick the particular port. For example, I selected port 3, and it shows you the metering data. It shows you the binary statuses that Sean mapped over on those master ports. And the nice thing about it here about the Orion is you can pick and choose the data that you want to send to SCADA. You don't necessarily have to send them all the data that you're reading on the master port. So for this case, we're going to go ahead and send them all our metering data, and we're going to send them as well as our binary statuses, and also maybe our conf-fail points. So notice here, I'm going to go ahead and send our binary statuses. But aside from that, notice that we want to make sure you see one thing. Each master port that gets created, NCD, one of the things that NCD does is it defines 3 additional points: conf-fail, polls, and responses. Polls and responses are counters. So as soon as the Orion initiates a poll, it sees a response, so they just keep counting up because it's a poll-based application. But in conf-fail status is just more of a binary status, and you could just, essentially what happens there is where Orion tries to connect 3-4 times, and if it doesn't receive a response, it basically sets its conf-fail points to a 1 to define to say that, hey, this device is offline. So we like to send that to SCADA as well, so I'm going to make sure I send that point to SCADA. Aside from that, I'm done with sending data from port 3. I could do the same thing by going to port 4 and making sure SCADA sees the points available from that port. So we'll send the binaries and the conf-fail and the analogs from port 4 as well. I will also send them the data from the Bitronics meter. So the Bitronics meter is on our port 24, our DNP client port. And here, instead of sending them all, we're just going to send them the currents, the voltages, the health status, and then bars and watts. And also, lastly, the conf-fail. All right. Aside from that, what else we got? We have our Orion IO. Again, notice that IO1 is a device. We gave it the device name that we gave it. But we're going to go to IIO client, and we're going to see all our statuses here showing, we're going to see all our binary statuses. We're going to see our analog statuses. And then we're also going to see our analog status here, and then our outputs are going to be under outputs, which we'll get to in a second. One thing I did want to point out with the Orion IO is you do have these conf-fails for each card. So notice here I have conf-fail binary inputs for card A, card B, card C, and card D. So you have a way of monitoring the status and the health of those cards within the Orion IO. And so some customers will take those and OR them together so they have one alarm for the Orion IO as well. That's something Sean will show you in LogicPak here shortly. But for us, so we're going to leave that alone, and then once Sean finishes up LogicPak, we'll take some of these conf-fail points and send them up to SCADA as well. Last thing we want to do with the SCADA master is make sure that they have the capability to send controls down. So we're going to go to outputs on the left-hand side, and we're going to make sure you see the outputs that we have configured from the Orion IO. We see all 16 outputs there. Another thing you notice is the alias, the description. Remember, we've configured aliasing earlier, so you're going to see that throughout the entire configuration process. You'll see a column for aliasing since we've basically configured it in the aliasing port. So we're going to take these controls and we're going to make sure we send these to SCADA as well. And notice the channels, so point addresses, they go from 0 to 15. That's going to be just fine for our application. If I go back to inputs, one of the other things that you'll see is that, notice I'm going to use this tool to kind of minimize since I'm done with this Orion real-time database area for now, notice that I can move this to the left and I have some details to look at in terms of how SCADA is getting that data. So if you start at the top, we have analogs. It just basically starts by doing all the analogs I mapped in, starting from 0, and it just it adds, it basically goes up by 1 for each analog input that I added in. Notice by default, all my analogs are in class 2. Again, I can modify that to put it in whatever class I want, but by default, analogs are going to be in class 2. Other than that, for my analogs, the default deadband is going to be 80. And notice my engineering scaling, that's going to be shown here. And this scaling that you see here is basically the same scaling that was on the master port. So by default, the way that Orion works is we match the scaling on the master port to any of the slave ports you're going to set up so that the data that comes in is flowing straight through the Orion, and we're not doing any scaling to it. But notice here you do have the option of doing your own engineering scaling if you needed to, going out to SCADA or going out to your HMI screen, or your logic or your alarm archiving. So there's a number of different places where you could do scaling, but by default, the scaling is going to be the same as it is on the master port, so that data just flows straight through, and you can maybe do the scaling on the SCADA master end. Aside from that, notice here, those are going to be my analogs. So again, my analogs go my first SCL device, and then my feeder 456 SCL 351, and then I have my 650 meter analog data here that I'm sending SCADA. And so notice that goes from 0 to 28 there. And then lastly, I have my binary statuses. And for the binary statuses, I have the binary points from my SCL 123. I have my binary statuses from my 456. Notice those are all in class 1. I did forget to include my statuses for my Orion IL. So I want to make sure that I send those across as well. So what I'm going to do is I'm going to go to my binary input card A statuses here. And I'm going to make sure I map those guys to SCADA as well. As soon as I map them, notice they just get tagged on to the bottom. So after the binary statuses from the SCL devices, I have my binaries for my Orion IO. And then lastly, I want to add in the Orion IO analog statuses. So I'll take those as well. All right, so lastly, I'll get my analog statuses from my Orion IO and get those added in. And so notice they just get tagged on right at the end of my analog statuses. One of the nice things about the Orion, it's also got these little tabular features that are available, one of which is reporting. So view report for current tab. And so this shows me exactly how this DNP slave port for my SCADA is configured. So I can send this to SCADA so they know exactly what class of data is coming in, how many points I have from each device, and what the scaling is. So you could definitely send them this, save it, print it, and give this to them so they could configure the SCADA master end. Another tool that I want to point out is going to be the edit common attributes tool. So for example, if I do edit common attributes here, actually before I do that, I'm going to actually go into the actual type of point. So for example, if I go to analog, it filters all my points just so that I could see all of my analog points. And let's say, for example, I wanted to modify the scaling for these analog points here. One of the things I could do is I could go ahead and utilize Edit Common Attributes tool and say, hey, I want to go ahead and change my scaling from 16-bit signed min to 16-bit signed max. And so now that I've done that, you could easily modify those kind of attributes so that you don't have to go into each one and make that change individually. So that is one of the really nice features of NCD. It's got these little tools available for you. Another one that's available that I want to point out is going to be the renumber reorder tool. This is a really nice tool in case you add in a spare or two. So let's say, for example, let's go back to all points, and or instead of all points, let's go to binaries. And so it shows me all my binary statuses. And I know I have a future device that I'm going to be configuring, so I could add in some future statuses that are going to be some placeholders essentially in this port configuration. So I could add in these spare ports, and for whatever reason, these are just like it does it by default. It's just basically adding it to the bottom of my addressing. So it's 29, 30, and 31. But let's say I want these points to be somewhere in between my binaries from my SCL device and my Orion IO. So what I could do there is I could go ahead and do renumber reorder. and it shows me my entire list of my binaries here. And I could say, you know what, I want to move these points right before my card A statuses. So I can move these here. And now that I've moved them here, now I could say, now readdress. You could see my addressing is 293031 still. I could go in and modify that, but the nice thing about renumbering OR is I can move those points and then I could readjust my addressing to the way I want to see it. And so now those points have moved in and I didn't have to deal with duplicate point addresses and things like that. So that's a really nice tool there if you're having to renumber or add in some spare points in your points list. With that said, Sean, I think it's going to be, you want to jump in and do a little bit of the LogicPak?
Yeah, absolutely. I had some questions come in that I do want to address. Actually, a few people asked almost the exact same question, and it's going back. Let's see if I can get some control of here of the port now. And again, they were asking what happens when you have multiple SCADA masters that are polling the same device. And it's really going to come down to application and kind of the architecture up above of what you want to do necessarily. So what's going to happen is as we bump up this number of max connections, let's say we had 3 devices polling, it's really polling just this one RTU device. So if any upstream, whether or not it's A, B, or C, for the site that polls this RTU1, as soon as that request comes down, hits our Orion, basically it's going to clear out the buffer of any of the points and it's going to go just out that one direction. So that works well, again, if you have, maybe it's the same utility and A, B, and C are just redundancies of all the same overall system and they share a common database, etc. Now, if it's the opposite case where maybe those different sites are perhaps different utilities, maybe there's a shared RTU inside of a substation and that data needs to get to all of the devices, it's not going to necessarily get all of the buffered data until maybe integrity scans come down, per se. But at that point, you could come back to the idea of copying the ports. You can build the RTU once, and then you can copy the port. It'll create another network port. You can even change your DNP addresses at that point again, but you don't necessarily have to rebuild your entire points list from scratch. If you have to make a change in the future, just delete your other ones, go back into your primary one, make all your changes, and then copy those ports again, change those unique parameters for the names and then perhaps the DNP addresses again. But that way you can quickly replicate your work and reduce the amount of work overall. So hopefully that helps clear up some of the questions that came in. But otherwise, I'm going to jump in, as Eob said, and start doing some of the LogicPak application. So to do the LogicPak, we're going a little bit out of order. And the reason we did that is because, again, jumping back into the inputs, oops, let's cancel that out. Let's go back to the inputs. One thing that we really did want to highlight is that we actually didn't do something, and that was the beauty of Cascade. We didn't have to create the master-slave relationship programming between our Orion LX Plus and our downstream Orion IO. You'll notice that as Eob configured the IO and then in the IO itself and then configured the DNP slave port in the Orion LX Plus, that all of these points were automatically available. So again, that's the beauty of Cascade. It really makes the multiple NovaTech or multiple Orion boxes, the different physical boxes, really appear as almost one logical unit. So again, it minimizes the steps and it keeps this common configuration between everything. So just wanted to highlight that portion. So jumping into configure, we're going to go into our Master LX Plus, and then we're going to go into Logic, and we're going to start doing some LogicPak stuff and the little common applications. So we're going to start off by going LogicPak's always online. We're going to click accept. Then we're going to go into our logic inputs. And what we're planning to do is we're going to showcase the OR, the AND, and the calculator functions. So in common mentality, we're going to click down to this OR function, and we're actually going to create a generic COM fail general alarm. So basically, if any of our COM fail points come in, basically those points turn to a 1 when the COM fail is true. So I'm going to start by clicking my green plus here, and I'm going to call this general COM And you'll notice it says drag server points here to add. So what I'm going to do is shrink this window over a little bit. Hopefully. Sorry, this is the remote control for me. And what I'm going to do is I'm going to utilize this search tool up here, and I'm going to search by COM. And you'll notice that I get, again, partial text of everything that has a COM fail in it. So I can grab this point, holding control. I can select the COM fail for both my Schweitzer 351s, and then I can find the COM fail for all of these different devices. And I can even find the general overall one for my I/O entirely. And then I'm just going to drag all of these over into my general COM fail. And what this is saying is that if any of these points here turns to a 1, it's going to trigger my OR function, and then my general COM fail is going to turn true, indicating that I have a communication failure somewhere within my entire substation. Now, if I jump over to my ANDs, it's going to work in a very, very similar fashion. And what I'm going to do is I'm actually going to do a similar mentality here. General X-former alarm. And the reason I want to showcase this one is EOB set me up perfectly here. If I go into the I/O on the Orion I/O and I monitor some of the Alias points here, I'm actually going to grab all of these different transformer alarms here. And in this case, if any of these points drop out, it's going to trigger that alarm for me. Meaning 1 is a good point. If it goes bad, it'll drop to a 0, and I can monitor that because my AND logic function will drop out. Now, one of the beautiful things about NCD here that makes it so easy, and I really like transformers as an example, is because if you have a very old bank that you're monitoring with contact, I've noticed that a lot of those older banks only have certain alarm points as Form A contacts and certain points as only Form B contacts. You never had the help of a Form C on there. So you had a mix and match of different contacts that you were monitoring. So in the past, that became you had to OR some together, you had to AND some together, you had to do an inversion in there somehow, put the whole chain together, etc. And so what you can do is that if you have a mix, again, of some Form A's and some Form B's, you can come in and actually invert the individual alarm contacts themselves as they're fed into this logic equation. So you can invert those points, again, on an individual basis, switch the equivalent contact type, bring it in, and keep everything visible on just this one screen, and then have all of that come in and feed my general transformer alarm. Lastly, we're going to jump over to the calculator type. And this is going to be kind of a faux example, if you will, but there's 2 buttons on this screen, the lower one being the calculator itself, and then the green one follows suit with what we've shown, and that adds the actual points. But the foundation or the baseline work is actually done in here in the open calculator. So what we're going to do is we're going to start by adding a calculation, and I'm going to call this, you guys have probably seen me do this example a few times. This is just the most common one I like to show, is add 3. And then my calculation is a matter of using these operators up above. It follows a Microsoft Excel style of syntax, if you will. But what I'm going to do is I'm going to do phase A. And these are just placeholder variables. You can name them whatever the heck you like. But I'm going to do phase A, phase B, phase C, and I'm going to click Save Changes, and then I'm going to go ahead and close it. Now, the reason I like to use this example is because oftentimes you will find in the field that like Cooper Form 6s, for example, are a great example. They give individual phases, but they don't necessarily give 3-phase totals of some of the analog values that are commonly metered. So what I'm going to do is, you'll see I clicked the green plus. It brought out a new calculation here. I'm going to go ahead and do the calculation of add 3, and those same values or placeholders that I created in my equation now appear here. So what I'm going to do is I'm going to mimic polling port 3 like this, And let's say that, oh, and it looks like we didn't pull back our individual phases, but you'll get the idea. So if I wanted we'll pretend with our currents now, what I could do is I could do 3-phase, total, we'll do current. Like I said, I like to do megawatts and megavars normally, but we'll add this together, and I'm going to go ahead and grab phase A, drag and drop, do the same thing for B, and then do the same thing for C. And what that's doing is feeding the analog values from this specific point, feeding it into my calculation, and overall I'm getting these 3 phases added together, summed up into this point, 3-phase total current, and I guess we should make that feeder 1, 2, 3, make it a little more descriptive, and that is going to be the total there. Now again, this is the foundation part, and I can quickly reuse and replicate that stuff by doing the exact same thing I would for my next. So I'll follow my syntax here, and we will do feeder 4, 5, 6 this time. Calc variable name, add 3. I'll switch my filter, just go back in and replicate the exact same thing, but on my next port. And what I'm going to do is just the same mentality of dragging, dropping, and putting those guys in there. So that is the summation of all those currents. Now, again, I said we did this a little bit out of order. We wanted to really showcase how well the cascading feature works with immediately putting points into your DNP server. So what I'm going to do is, now that we have these points configured, I'm actually going to go right back to the DNP port we created previously, or DNP server, that I should say EOB did. And in the same exact idea, I'm just going to go ahead and go all the points for laziness, and I'm going to now filter by my LogicPak. So if I go to port 26, LogicPak client, in here are all of the points that I just created and named within LogicPak. And so now I can send over my COM fail general, I can send over my transformer alarm. Again, you'll notice that these are just appending at the very last of the DNP points that we created, so I could use that point address renumbering tool that EOB showed if I needed to. And then, of course, I can switch over to my analogs and watch the exact same thing happen when I add in my 3-phase total currents like that and send those over. Again, appended at the bottom, and that gets any of the points that I created within LogicPak quickly over into my DNP server port.
Awesome. Thanks, Sean.
Yep.
So the next thing that we want to, when we started, we mentioned the configuration of the devices, and then we mentioned the configuration of 3 different applications. So we've just configured, Sean has just configured the LogicPak, which was one of the applications that we wanted to configure for you all. The other application that we want to configure in this session is going to be alarm archiving and creating a one-line screen. So the next thing I'm going to do is I'm going to create our alarm archiving port, and then I'm going to make sure we have points that we're archiving and that we're doing some type of alarm annunciation as well. So with that said, I'm going to go to my configure tab, and I'm going to again notice that I'm not going down to my I/O configuration too much. All I did in the I/O configuration was define my carbs. I could have done more logic, I could have done other applications there, but we're doing other applications on the primary Orion LX Plus RTU. With that said, I'm going to go to client, and I'm going to go to add-ons. So I was here earlier to configure the aliasing, the description. All right. So now I'm here to configure alarm archive retentive, also known as alarm AAR. So I'm going to go ahead and open that up. And this is going to be my configuration window for alarm archiving and retentive. And so one of the things you notice here in the navigation section here under general, one of the options that I would keep an eye on or make sure I select is going to be make sure archive is enabled there. All right. You also have other alarm options where you could enable alarm archiving, retentive alarm enable, automatic acknowledge return to normal alarms, and display device time. So these are some additional features of the alarm archiving module, I'm going to go ahead and actually select on automatically acknowledge return to normal alarms, display device time, and then alarm archive enabled. And then retentive. I'm not going to do retentive in this session, but we could check that as well for now. And we will also retentive enabled here if we wanted to configure retentive. So we're going to accept those changes, and now I'm going to go ahead in my navigation area. I'm going to go down to my inputs tab. So notice here on the right-hand side, I'm going to go start by just mapping in one binary, one analog point. So let's go ahead and take the COM fail from our feeder 123 SCL51. So I'll map that point in. That's a binary point. So notice whenever you map one point in, you have a few different options to select from. You have the point name, you have the aliasing, again, the description that we've enabled, and again, this is by default. You'll see the device name underscore the point name. You'll see some scaling functionality, so if you wanted to scale it in aliasing, you can, but again, it's 0 to 1, so not much to scale. But the big thing I wanted to point out is going to be these checkboxes here. So you have two alarm checkboxes. So if it's a binary point, binary alarm is going to be checked. If it's not a binary point, just alarm enable is going to be checked. All right. If I want to archive this point, all I would need to make sure is this archive option or checkbox is selected. If I wanted to make sure this point was retentive, what we mean by retentive is when the power Orion RTU goes through a power cycle. If I wanted the Orion to retain that the value of that point, I would need to make sure this checkbox is checked, is selected. So again, we're not going to do much retentive. I'll leave that alone. But the one thing we do want to do is make sure archive enable is selected. We want to make sure this point gets archived. We also want to make sure this point gets incorporated into our alarms. So I'm going to make sure this point has alarm enabled. By default, notice binary alarm is selected. By default, it also selects retentive. Again, if the RTU, and the reason this is automatically selected when alarm enable is checked is so that if the Orion goes through a reboot, you don't want to get all these new alarms coming into your system. So that's why by default, it automatically checks retentive. We can leave that checked if we want, not a big deal. So now that we've done one, I'm going to go ahead and do a number of other points. So I'm going to go ahead and do a search for all my COM fails. So I want to make sure all my COM fails are configured in here. So we've already done the first one. So I'm going to go ahead and select COM fails for my IO. I'll leave the card statuses because we've already done a general COM alarm. So I'll take that, and then I'll also take my COM fail for my IO and then my meter. So I'll make sure to take those. Instead of the FMD COM, I want the COM fail. So I'll do that, and I'll map these guys in. So these are all my binary statuses that I've mapped in. Notice that by default, they're unchecked. So what I could do is I could do edit common attributes, and as they're all selected, I could say alarm enable all of them, and then I could say archive all of them as well. And so since I'm doing alarm enable on all of them, by default, if they're binaries, it's going to check this for me, and then by default, it's going to check retentive for me like I described. So I'm going to hit apply, and that's what you'll see on the right-hand side. So now that these points are configured for archiving as well as alarming. So we could do a little bit more detailed configuration of how we want to archive and how we want to alarm in these tabs down below. But for the first thing you want to do is make sure these points are mapped into the right-hand side and that you have these checked. Aside from that, what I'm going to do is I'm going to go to archives, and I'm going to notice there within their binary points. By default, it just has them as an event. So whenever they go from 0 to 1 or 1 to 0, it's going to basically put it in your archive, in your PostgreSQL archive. Notice there I have other options for analogs and things of that sort. If I wanted to do timed, I could say, hey, every 15 minutes, go ahead and archive it, or I could do, both event and timed. Even if it hasn't changed, go ahead and archive this value for me every 5 minutes, as well as anytime it changes, archive that value for me. So you have a number of different options. You have about 3 or 4 different options how you could set that up. But we're going to leave these as event, and if they change from 0 to 1, 1 to 0, I want to make sure those appear in my log. So that's going to, and then in terms of the alarm configuration, again, we haven't done any analog alarms, so we're just going to go to binary alarms. And then notice there I have a couple different options of, I have my point name, my alias, and then I could define an initial value So if I say the initial value is 1, then it's not going to be an alarm until that value goes to 2 and 0. So I can define that. I have some tools to I have some options to categorize my alarms in terms of this zone category, this zone column, or on and off columns. So I could kind of categorize and make sure my alarms have a good description, and I could also use that for filtering purposes as well. I'm going to leave it at 0 for now. I also have a tool to define multiple different alarming groups. So if I have my technicians group, my engineers group, I could say, hey, this is going to be only acknowledged by whoever has permissions to alarming group 2, or alarming group 5, or alarming group 1. So you can kind of define that in user privileges. So we won't get into that today, but again, I'll leave these as, let's go ahead and select all these points, and we'll just put them into alarming group 1. So we'll do a drop down, select alarming group 1, hit apply. All right, so now you can see all those points are, so whoever to acknowledge these alarms, the user has to have the permission for alarming alarm acknowledgement group 1. So that's really all there is. And notice there I have an on and off message as well, so you could define exactly what this confail means. So if I wanted to say confail, or if off message means normal, I can kind of define those kind of states there, and then what the normal state is going to be, whether it's open or closed. So you have some additional configuration that you could set up here for alarm archiving, but I just wanted to kind of get into there so we can map in some of our confails into alarms. In addition to that, one other extension of alarming is this Annunciator tool. So you guys can see this Annunciator. This is basically a web-based Annunciator that we could configure. So it's a pre-formatted web page that's within the Orion. So if you have it configured, all you have to do is hit a certain URL, and that page will come up for you, and you could define how that page looks right over here. So under Annunciator, I could add a couple different pages. So for example, I could say add new page. Under page 1, I could say comm alarms. And then I could say, let's go ahead and add a second page, add a new page, and I could say transformer alarms. Transformer alarms. And then so now that I've done that, I could go ahead and see, so now I have 2 pages. Notice here, you can see them here, comm alarms and transformer. And then for comm alarms, I've already got those points mapped in. I see them right over here. All right, since I've already configured them as alarms, they show up right here for me already. So all I really need to do is make sure I have the right number of rows and right number of columns defined. All right, so right now we have a 3x3, but if I'd say, you know what, I want to do a 4x3, I can certainly do that. And then all I would need to do at this point is map in these points right into the right-hand side. So select and hit this little button here. So now I've kind of, built up my tiles. I could move these points around onto different tiles. I could also rename these tiles by selecting this option here, and I could say, you know what, right now they've taken the name of the device, of the point name, so I could kind of modify that, customize that a little bit if I want. And so that's all you really need to do for configuring that. And then now that let's say I'm happy with how this looks, I'm gonna go ahead and move this up a little bit. Let's say I'm happy with the way this looks. In that case, I'm gonna go to my second tile page, or my second page on my Annunciator, and notice there, I don't have any of my transformer alarms. So what I'm gonna do there in that case is I'm gonna go back to inputs and make sure that I have, let's go to our Orion IO, and these are some of these hardwire transformer alarms are. I can map these guys in to my right-hand side, and I can make sure these points are also alarm points. So I could say edit common attributes, make sure these points are alarm. Sorry about that. So now that I mapped them into binary alarms, they're already checked for binary alarms. I could go ahead and select these points. And then do edit common attributes, and I'll also put these in alarming group 1 as well. Apply. So now that I've mapped them into binary alarms, now if I go to my transformer, notice you'll see those binary statuses here. I can say, all right, these statuses, how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 statuses, and what is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll add in another row. So now that I have 4 rows, I could say, all right, let's take these binary transformer statuses and map them in. Notice as soon as I map them over, the default tile name is what we had for aliasing. So that's another benefit of aliasing, is that whenever you're doing these annunciators, that's kind of, by default, the primary name that we use is the point name. But if you have aliasing configured, we'll populate this section with the alias name. So now that we've got that, there's really not much we need to do on the alarm archiving retentive configuration. I will save this configuration file. Let's go ahead and save this file. So file, save as. I'm going to call this north sub, and I'll put it under power hour. So I've saved our configuration file.
One thing I do want to point out too, kind of went unsaid, sorry to interrupt, is order of operations kind of plays a huge role as you go through this. You'll notice that as he was going through the alarms and the tile names were already there following the aliasing and whatnot. If we had done alias after configuring AAR, those tile names would have taken the original point names, and then we would have had to come back in and do a lot more manual process. But by doing alias prior to all this, it really helped automate some of this process and make it a lot quicker. So I guess, again, that's one of the things that kind of went unsaid as we went through this thing, but do keep order of operations in mind, as that can really help streamline your configurations.
Yep, that's a great point, especially if you could knock out aliasing, if you decide to utilize that function right after you set up your master ports, then you'll be able to see it throughout the configuration while you're doing logic or alarm archiving or even tile annunciator. And even when you're setting up your SCADA port, that description will be right there for you to kind of guide you, make sure your things are falling in line. So that's a good point, Sean. Order of operations is definitely important. So now that I've saved this configuration, the only other application that we have left to accomplish is going to be creating, making sure we have our HMI screen created for our one line. So now we've saved our file, we're going to come back to that last application in just a second. I'm going to go ahead and load our configuration file into the Orion and see how our connections, our communications is going. So with that said, I'm going to go ahead and open up our my browser. I'm just using Google Chrome. And all I have is I have my Orion IO on the same network as that SCADA network that I've set up on to that Orion and the Orion IO. And so I have 2 tabs. I have my Orion LX Plus tab here, and you can see there under Home tab on the home page there. And I also have my Orion IO tab here, so right next to each other, 141 and .142. For the configuration of the Orion IO, like we've talked about, we're utilizing the cascading application to configure the Orion IO. So what that means is there's one thing I need to do in terms of getting the Orion IO ready to accept the cascaded configuration file from the RTU. And that is, go to the web interface of the Orion IO and simply go to settings. Once we go to settings, we would need to make sure we go to cascading slave and define the IP address of the master RTU. So essentially, in our application, our master RTU, the Orion LX Plus, is at 172.16.68.141. Notice the TCP port address is the same 5001 that we saw earlier. And again, I'm going to disable the SSL security encryption for that. So basically, as soon as I make this definition here, all I do is make sure I do save and make active. As soon as I do that, what you'll see is this Orion IO, the file that's currently running on the Orion IO, which is orionio.ncd, that file is going to change. It's going to be, you'll see what I mean there. So I'm going to hit save and make active. So notice there, my slave.ncd is starting. It's starting, and it is running. So notice there, cascading master, it's still not connected to our RTU yet, which is just fine. But on Orion IO, that is really all you need to do when it comes to cascading. You basically tell it to be in await mode from that particular IP address so that it could get a configuration file. So that's all we've done on the Orion IO, and we'll come back and see if this configuration file changes when we load our file into our RTU. So now this is our Orion LX Plus. Let's go ahead and go to Files. And we notice the file that's currently running is Orion LX1.ncd. And then the other file, if you guys are wondering, this Orion LX.ntk, that's what we call the key file for each of the Orions. You'll see that on any Orion that you're looking at here. So at this point, I'm going to go ahead and go to my files, and I'm going to take the file that we just created, 1121. Yep, sounds about right. I'm going to drag and drop this file right into my files page. All right, so now when I drag and drop it, I haven't loaded it yet. I've just simply placed it on my Orion. Now I am sending the file to the Orion, so it can be stored on the Orion. You'll see that now my new file that we just created is shown there, and all I have to do at this point is make it active. Notice now I have two .mcd files. So the one I want to activate is going to be this North Sub RTU cascading, the one that we were just working with. So I'm going to go ahead and activate that. As soon as I activate it, you can see in the header bar that the new file is starting. As soon as it's done, it looks like it's done running. So we'll go to devices and kind of keep an eye on some of the devices as they come in. All right, looks like doing some initialization with our end devices. It looks like our Bitronics meter is communicating. The SCLs are probably going to take just a second just because we have them on auto baud. So like Sean mentioned, it's trying a couple of different baud rates and making sure that those baud rates are good. I need to double check okay, good. So still looking for the auto baud. Looks like my SCLs are now finally seeing, they found the right baud rate and they are communicating as well. And then it looks like our client, which is this guy right here, the Orion IO, that's also online using cascading. So if I go to the Orion IO and I go to devices and kind of refresh the page, notice now it has a new file name which is called cascaded-device1.ncd file. So it's running. So that's originally when we looked at it just a second ago, it was a slave.ncd if you guys recall. So now we see cascaded-device1, which tells me automatically cascading is working just fine. One of the things to notice about cascading, whether you're looking at it from the IO perspective or from the RTU perspective, is that it's not a pole-based application. So earlier I mentioned one of the big points about cascading is it's a network-based application, and it's got a few benefits to it in terms of making the configuration easier and also being able to manage only one file instead of multiple files for multiple Orions. But in addition to all that, it's also a event-driven application. It's not the Orion pulls it and it doesn't wait to get a response. It's an event-driven application. The only time you see these numbers going up is when an event is reported from the end device, from the Orion IO up to the RTU. So for instance, if I go to data values here on my on my Orion IO and go to the IO card, go to the IO card here under inputs, and if I force binary input 1 on the Orion IO, and again, forcing is a tool for troubleshooting and commissioning, so it's really a nice tool there. So I'm going to force binary input 1 on my Orion IO. Oops, it was actually, yeah. So if I go to my RTU side, now I'm jumping to RTU and go to data values, you'll see that, I'm sorry, before I go to data values, under devices, you'll see that that event triggered this polls and responses to increment by 1. So that's really what I wanted to show you. It's really an event-driven application. So as events come in, you'll see those numbers go up. So at this point, we have our devices talking. It looks like our 650 is talking. It looks like our Orion IO is communicating as well. The last thing that we wanted to accomplish today is going to be just creating one system, one line that we could make live. So for that, I've already built a one line to save us some time. What I'm going to do is I'm just going to add in a couple breakers and some analog data to show you exactly how the full configuration of the HMI screen is created. So now that you see here, we've kind of built up these objects, these breakers, these analog data, and then we have some static descriptions like the volts, megawatts, megavars, and the line names and so on. So what I'm going to do is I'm just going to go ahead and create an object. So all I'm going to do is I'm going to create 2 breakers here, one here, and then we're going to create, just like you see here, I'm going to create a megawatts, megavars reading here, megawatts, megavars reading here. All right. So I'm going to go to, I have my toolbox essentially here on the left-hand side, and I'm going to go to the icon that's going to allow me to create rectangles and squares. So I can create my first object. So I'm going to go ahead and kind of create my my initial object, and kind of that looks about right. And I could go ahead and escape, use a little select cursor tool, and be able to kind of move it around wherever I want. I could duplicate this object by hitting Control-C and copying it here as well. So at this point, all I'm going to have to do now is go ahead and create my megawatts, megavars descriptions. So we'll go ahead and use a text tool for that. So megawatts, notice when I start typing in text, it's black. So what I could do is I could go ahead and use the color wheel, or you know, I could use the color wheel, or to make it into, actually instead of the color wheel, let's go to, we'll make this completely white. All right, so that looks a little bit better. I'm going to escape out, and I'm going to use my hand cursor tool again. So I'm going to make this a little smaller. I could even compare it to these guys and make it a little smaller, but again, we're restricted on time, so I'm going to say that's going to be good there. I can make this a little bigger, and we're just going to focus on creating these objects here. So we have our megawatts here, and I could copy this text, and I'll paste it there, and this time I'll double select and type in megavars. And now that we have those two, I will take both of them. So I'm going to use these as just a static text. They're not going to change. So I'm going to copy both of these though, and I'll paste it here. And instead of doing megawatts, megavars, I'm going to change it to the number sign. So just a few characters there, as well as here. So now I'm going to assign my points that I want to be changing, my my dynamic points, and then so this is going to be the object that I'm actually going to configure with the metering point. So I'm going to take those, and that looks good to me there. So I'm going to just kind of clean it up just a little bit, just move them a little closer. Now that I've done that, what I could do is I could select all 4 of these objects and copy these and put them on this side as well. And I might want to put this, my numbers on the left-hand side. So I might just go ahead and move these to this side. All right. So that's going to be as much as I'm going to create. So assume to save time, we've kind of just created the rest of the one line. And I'm not going to be animating these other screens, but I do want to make sure I animate these objects here to show you exactly the full process of creating the object. And now that we've created the object, we have to animate the object. So to animate the object, there's 2 things that we need to do. The first thing we need to do is make sure we have our NCD configuration correct. We have our configuration on the NCD side done, and then once we do that, we'll need to configure these objects by coming back to our drawing. So it just depends on the order of operations of how you want to keep this accomplished. But what we've done so far is we've actually just created our graphics in Inkscape, and now we could jump into our NCD software and go to Configure. And we're going to go to our RTU configuration tool, and we're going to go to network, because again, our HMIs are more of a network-based application. We're going to do configure new port, and when our dialog box comes up, we're going to select XML slave, and you guys, XML server, which is shown right here. XML is the way we do data transfer from the Orion to our graphics. It's a data transfer method that we utilize on the Orion. So we're going to use XML protocol to get this completed. Now that we've opened up XML configuration window, Notice here, there's really not much we're going to have to do over here. Instead of, we have added in this little point ID description where instead of the point name, if you want to use the alias name to assign those points to our HMI screens, we did make that available, but I'm going to keep with the point names. That's what I'm used to. So under port, there's really not much to do. All we do now is add new file, and this file is what's called an XML file. This is basically a file that's going to contain all the data that's going to be used to animate the graphics that I just showed you. So we've created a new XML file, and we're going to go to change this name instead of file 1. We'll call it OneLine. We change it to oneline.xml. I'm going to hit accept. So all I did was update the file name, but the oneline.xml, and we're going to just go to inputs. So notice here under inputs, we have all the points that are available in our Orion database, just like we had on our SCADA master port. So in this case, I'm going to get a couple of things. I'm going to get a 52A status. So 52A, we're going to grab that from our two SCL 351s. We're also going to grab our megawatts and megavars. So we have our megawatts for the 2 feeders. We'll grab those. And then we also want to incorporate in our megavars. So we have our 3-phase megavars. We'll make sure we map those points in as well. So we have 6 points, and if you're looking at the graphics, those are the 3 things that we want to configure for each feeder. Sean, do we have any questions on the HMI side of things so far?
No, doing good.
Okay. So basically now these are the points that we're going to use. So all we did now is essentially define the points that are going to be available for us to animate our graphics, so each of the different objects. So this is going to be the first component of creating those HMIs. So the first component, was creating the graphics. You could do it vice versa. But in this case, we did the graphics first, and then we did our NCD side second, which is defining the points that are going to animate that screen. Now we need to make sure we tie these points to the objects on our graphics screen. So three different stages to the HMI side of things, but not too bad there. So now that we've got 3 of these points in, one thing that customers always, not even customers, even I forget, sometimes whenever you're working on this kind of configuration file, whenever you make a change to the XML port and add in a new point, like maybe a conf fail point, so let's add in maybe a conf fail point. So if I added in the 2 conf fail points, for example, you might forget to save the configuration file. So you want to make sure you save this config file after you add in additional points to this XML port. That's how you're going to be able to see those points exist on the graphic side of things. So you want to make sure you keep this file saved and updated as you add in additional points. Just wanted to add in that side note. But what we're going to do now is we're going to go back to our graphic screen, and we're going to basically take these points that we have in here, and we're going to assign them to the different objects that we just created. So let's go back to our graphics. I'm going to zoom in a little bit.
Quick question. Customer just brought this up. Can you just how we can modify the decimal placement on the analogs?
Yep.
Or is it going into XML?
Going into XML. Okay. Do you want to cover that one, or I thought you were talking about this guy right here.
Oh, sure. Yeah. If you don't mind, click back into NCD and then just show the scaling.
Let me see. So if you're looking at scaling again, you'll see it here. You want to, well, I'm not sure what the question is referring to. If you want to go ahead and see if you could address that a little bit.
Yeah, so what's typical is, and this is going to depend on the configuration and the parameters in your end IED, but what we typically do is we'll do one-for-one mapping from an IED back up to a SCADA master, just so that way we can use the concept of preserving the decimal. DNP is only capable of transmitting integers, and so in the case of, I like to use frequency for an example, if I had a perfect 60 hertz, typically the raw value transmitted would actually be 60,000, and that way, again, that serves as an integer base, but it still has that decimal representation when that value is then divided by 100 once it finally reaches its end destination, termed recovering the decimal. And so in the case of if we were recovering values at just a raw, say, I'll say minus 32,000 to positive 32,000 from a device, but we wanted to recover that decimal for the way that it's displayed on the XML portion or an Inkscape, as it's served into XML here, we actually might divide that value by 10 or by 100 or whatever, you know, decimal movement we need to do to actually recover those numbers and then have them properly displayed on our Inkscape screen. With, again, doing that just in XML, but not through our server port back to our SCADA masters. So hopefully that addresses what the question was that came through.
Okay, thank you, Sean.
Yep.
So with that said, I'm going to go back into the graphic screen. So now that we've built our graphic, we've built our XML port that's going to be used to for me to pick and choose the points I want to use to animate this graphic. So now I'm back in here and I want to, let's say, configure each one of these objects. So I have 6 different objects to configure. I have this guy, this guy, this guy, this guy, and these 2 objects to configure. I'm going to be configuring the megawatts and megavars here, and then the megawatts, megavars here, and then the breaker statuses I'm going to tie to these square objects so they change colors. Notice by default they're yellow. We like to do that because a lot of times we'll use green and red for open and close on these breakers. So yellow allows me to know if that point is actually functioning correctly and working. So that's kind of why I have it in a yellowish tone there. So what I'm going to do is to configure these objects, what I'm going to do is I'm going to utilize what the extensions that are built into Inkscape. So in Inkscape, there's under Extensions tab. And so when you install NCD, there's 2 extensions that were installed with your Inkscape installed. So the 2 Inkscapes are the 2 extensions are HMI extension, HMI library, and templates. This is really nice for grabbing certain objects like transformer symbols or, you know, circuit open symbols and things of that sort. And so it has faceplates and from different manufacturers, whether it's GE or SCL, so that you could actually have a real have a good visual of what you're seeing at the substation level. So that's what HMI library templates is for. But what we're going to use today is going to be our HMI extension so that we can make some assignments. So we're going to go to HMI and keep in mind that I have this object selected here, the 1325 breaker. So I'm going to go ahead and select HMI extension. As soon as I do that, what happens is this extension basically looks at NCD. This looks at this XML. This looks at this XML port, and it looks at these points that are available here. Again, that's why I mentioned earlier. You want to make sure this is saved. If you add new points and things of that sort, if you add a point and forget to save it, Inkscape, this extension will not see that point until you've saved that port. So keep that point in mind as you're working on a project. But notice here, the things to notice automatically is you'll see the file that we have open in NCD that matches exactly the same. The other thing you'll notice there is our XML file. We only have one at this point, so oneline.xml, you'll see that there. The other thing that we're going to do here is we're just going to define the points we want to assign to this. So notice here under point, we'll do the drop down and select, let's just do the one, we'll consider this a 50 feet or 123. So we'll do FMD52A. And so now that we've selected the point, that's a binary point. So under color display, we'll do binary. And notice the color scheme red or lime for on and off. If you wanted to change that, you could certainly do that to make whatever color you want. But that's all we're doing. We have other tools in here. So if you wanted to use a hide function or make it blink, or make it so that whenever you select it, it performs an operation, you could do all those things here if you wanted to. But for our demonstration purposes, we're just going to assign it to a breaker status. So I've done that one. I'm going to hit OK once I'm done with that. And I'm going to go ahead and move on to the second breaker. So I'm going to go ahead and select my second breaker, 1709, and then I'm going to go to extensions, HMI, same concept. And notice none of this changes here, just oneline.xml, everything looks good. We're going to go ahead and select our second feeder. So we'll do the 456, and we'll do binary. Make sure red and lime are selected. That looks fine to me at this point. And for our megawatts, megavars, we'll go ahead and select each one of these as well. I'm going to go to select that object, extensions. I'm going to do HMI. And we'll do the drop-down selection and make sure we select the 456 megawatts there. And this one is going to be It's not a binary. This is going to be a decimal. Again, it's the text that already knows it's a string, so it's saying what kind of string is it. So we're going to see it's a decimal. So we want to show us a value. We'll do a decimal. And we'll say, give it a 1 decimal place in the display. We could change the color if we want, but I'll leave that alone. Hit OK. We'll do our megavars, and we'll do the other feeder. So let's go ahead and send megavars there, and we'll go to HMI. And this time we're going to do megavars for the 456. So we'll select that feeder there, and we'll do a decimal for this text, and we'll change that to a 1. And then we have a couple more objects left. So this feeder here, we'll select that object, do extensions, and we'll do HMI, and we'll do megawatts for feeder 1, 2, 3. We'll do a decimal again, and we'll make that decimal place 1. And then the last object that we're going to configure for our demonstration is going to be this guy right here. Select that. Notice that I have to select the object before I go to extensions and hit HMI. So I'll do that. Hit HMI there, and I will make sure that's assigned to megavars 123. We'll select that, and we'll make this a decimal. And all right, so now at this point, this HMI screen, at least these 4 objects are configured the way we want. I did have this pre-configured to show all online, but our device names are a little different. So those show all offline at this point, which is fine. All we really care about is these 4 objects that we've configured so far. So with that said, I'm going to go ahead and make sure I save my graphics, my Inkscape SVG file. Let's go ahead and save that file. And all you're going to want to do is you're going to want to take that file that you just saved, go to your RTU, go to Files, and we're going to drag and drop that file right in here. So we're going to go to our folder, and this is the one we just saved, 1148, yep, it's the latest one. I'm also going to update my NCD file as well. And the reason for that, it's easy to forget, you did make some changes in there since the last time we loaded that NCD file in here. So I'm going to load both of them in. One of the nice things you'll see about the Orion is that when I load the NCD file in, since it has the same exact file name, it's automatically going to go through the process of making it active and making sure it's updated. So I'm going to drag and drop both of these files right in here, and I'm going to do send. Notice when I send it, this new updated NCD file is starting, and now it's running. Notice that my SVG file, which is my graphics file, is sitting here. All right, and so there's a couple things I want to mention at this point. The points I want to make is how do I view this SVG file or this graphics screen, this HMI screen that I just created? With the Orion product line, there's a couple different ways. So you could take this, if you try to just click on it right here, you're not going to like the view. It's going to give you like a web-based, you're just trying to open it up in a non-proper format. So what you want to do is instead of selecting it here, what you want to do is you want to make sure that this one line shows up on your home page, which is up here, or it shows up on a link bar, which you could set up here. So for that, we're going to go to Settings, and we're going to go to Web UI. Hope everybody's there with me. And we're going to go to Web UI, and this is going to be where I could put it. If I notice there, I see my web files, and if I select that, if I make the selection, what happens is it's going to basically appear on my home page. So let's go ahead and do that real quick. So if I hit save, notice that I've checked this guy. And if I basically go to my home page, now I'll be able to see that SVG page on my home tab, and I'll be able to link to my one line from there. That's one of the options. The other option is to utilize what we call a link bar. We'll get to that in a second. But with this user link here, if I select on it, notice that we'll see our other objects not configured, which is fine. That's what we expected. But we do see our objects looking pretty good. Again, it's the color that we want. It's green or red, which is fine. And then our megawatts, megavar values are 0.0, which means it's reading something. And what we wanted to do, what we could do for further testing is we could go to, for example, I could open up another tab. Let's open up one other tab. And you bear with me one second. I could open up another tab for my Orion RTU. And here I could go to data values, and I could say, let's go to my inputs port on port 3, for example. And you can see here on this tab, I have my one-line screen. So I have my one-line screen here. I could, on my other tab, it's the same Orion. What I could do is I could force the 52A status, which is down here. If I force that to a 1, force value, notice the value has been triggered here. And notice the force column says yes, it's a 1. Now I go to here and I could see that is depicting the way I expect it to, which is red. And that's all, that's the big point there. And you would just go, essentially, if I had the full configuration of this graphics tin, I would go through each object, make sure everything is responding the way I expect it to. So that's going to be, that's going to sum up the configuration of the HMI side of things. Anything you want to add there, Sean? Was there any questions so far?
Yeah, I got one question, but if you don't mind, just since you were really close to it, let's go back to the web UI and show the link bar, and then we can also throw in the tile annunciator visual.
Yep. So that's a
great. We did have one question come in. I'll take afterwards, but how to possibly build some templates in
Okay, we'll come back to that one. So settings. So again, one of the things that Sean just pointed out is we are able to get to this one line by going to web UI and making sure that's checked, and so that it could show up on my homepage. That's one of the options. The other options is what we call a link bar. And to set that up, you actually go to the same place. So you go to settings, and we'll go to web UI. And when we're in web UI, you'll see here I have an option. I have a section called link bar. That's basically what I'll show you in a second. Let's go ahead and create, so we're going to basically create a link here. So we'll just do SVG, which is just an SVG page, and then I think we called it oneline.svg, and we'll give it a name, one line. So what happens here is that I've created a link. At this point, it's just one. Notice that I only have a place to, I only add one at the moment. And notice here down below for the different pages, like the home page, the files page, the settings page, I have options to show link bar. So I'm going to go ahead and select those and make sure so that I could see my link bar when I go to the home page, for example. Because right now when I scroll up, you don't really see anything but aside from the blue header, the Orion header. So I'm going to go ahead and select show link bar on all the different pages. Actually, that's good for now. We'll leave that there, and I'm going to hit save. So notice as soon as I hit save, notice now what I have this gray bar up top. That's exactly what the link bar is. It's basically a section where you could put your own custom user-defined links in there. It could be links that are on that are related to the Orion, one of the Orion applications like redundancy or HMI screens or Annunciator. So any one of those. It could also be links to any other device that has a web interface and that's on the same network as that Orion RTU. So you can kind of browse to that page. So what we're going to do at this point is we've added our one line. Notice here, that's what you're seeing, one line up here in my link bar. I'm going to add a second link. To add a second link, notice now when I hit save, it gives me a second line. So for this line, I'm going to add Annunciator. I spelled it right, and then I'll call it ANNUN. So when I go down and when I save it, notice that it gives me a third line it keeps giving me lines until I guess I run out. I haven't hit the maximum yet. But notice my link bar, I have two links now. If I hover over them, you'll see the link in the bottom left-hand corner. So this is linking to my one-line SVG. So if I click that, maybe I spelled it wrong. Did I spell it wrong? Let's go double check. Oh yeah, I think definitely named it wrong. So we're gonna go to, I'm gonna take the name. Let's go back real quick. Forgot I had North Sub in there. So I think I called it North Sub one line. I think that looks better, guys. So we called it SVG North Sub _ one line.svg. So now let's go ahead and save that link or save this page. So So you can see my one line still there. You can see my link has been updated. If I select it, it takes me to my one line page. So this is one way. This is a second way to get to those HMI screens that you create. And then now if I go back home, and the other link that we have here is the Annunciator link. Again, this is going to be for what we created for alarms. So if I click on that, it's going to make me log in. So let's do that real quick. Did I misspell something? I think I misspelled it. Give me 1 second. So again, mistakes happen in this live demos, but not too bad today. I think I'm misspelling, right, Sean? Yeah.
Sorry, I was typing on questions, so I wasn't watching too much.
Did I spell that right? Did I look right to you?
Oops, sorry, I was on mute. N before the C, Annunciator.
Oh, okay. And before the C, okay. I think, okay, good. Sounds good. So we'll save that. And now we'll try to link the correction and our tile annunciator drop. So with the tile annunciator, you guys saw me configure it earlier. The configuration is fairly straightforward. It's really defining how many pages, how many tiles, and how you want that arrangement to look like. But for the most part, that's all there is to it. Was there anything else, Sean? Was there any questions on, aside from?
Yeah, one question came in is how do we make the one line be the default page that you log into?
Oh,
and so that
okay.
Quick answer on that one is basically just take that exact link that's shown as you're on the web on the one line, and then you can just browse to that page if you like. The other thing that you can do too is, which is very handy for say the HMIs that are actually left in the substation, is that if you go to settings and then web UI, near the top, there's actually a timeout here. And so it's an inactive redirect. It says auto redirect after the user is inactive for a set number of minutes. So 0 is basically turning that feature off. But what you can do is say, 20 minutes, 30 minutes, however long you like. If a technician walks away or leaves the substation, basically it's going to return that HMI directly back to that one line, so it's in that default state for the next guy who comes in to work with that system. So a few different ways of going through that.
And you would basically take the link and put it right here. And I need to double check if we need to put the SVG on that one, but essentially all you're doing is putting that URL link to that one line right over here. So I could, so that I think addresses that question there, Sean.
Perfect.
How are we doing? So right at 2 hours. I wasn't sure how long this was going to go. So thank you for those of you guys that were able to stay with us. Hopefully we covered a good amount of topics for you guys in enough detail that things made sense. But aside from that, Sean, should we go through the wrap-up slides, or what do you think? Or is there anything else we want to address?
Let's go ahead and do that. If you don't mind, click back into Inkscape. I want to show one quick idea of how to do a template there.
Okay. Oh, the template question. You're right. Okay, go ahead. So should we go into the templates?
Okay, sorry, I was making sure I still have my room available. So
Okay.
one of the questions came in of like, how can we minimize the amount of rework here, and how can we just basically build template files and then reuse those from one project to the next? And so I'll go over a few little details here. So one thing as Eob kind of touched on is basically we have a bunch of yellow rectangles and or breakers, if you will. And the idea is that way if we create something visually speaking, and we forget to apply the programming behaviors to it, it's going to show up as that yellow indicator, and it's going to tell us on the HMI screen that, yes, we missed the programming. And unlike this green box here, which we didn't put any programming into, but yet since we drew it green, it's giving us a false indication, which might translate to a safety hazard when it hits the field, and so on. So what we can do is we can actually take some of these breakers after we create just one of them, and if I duplicate that out, and this is how I can take something that I've created once and then reuse that. So what I like to do is, as Eob showed, extensions HMI, I can actually just hit the / or the question mark button on my keyboard, and it brings up this box for us right away. And so what I can do is I can actually deconstruct this object a little bit. And you can use this for the analogs and so on and so forth. But what I can do is I can actually just select this point out of there, remove the association it has, and press OK, and now it's going to actually break this box. Now, if I right-click it and get into kind of a power creation here, and I go into object properties, this is actually going to show me the behaviors that that tool or the extension was actually doing in the background for us. So it looks like it did a little mishap on me, just probably because I'm working through EOB's computer remotely. But the other thing that I can do is I can actually just remove this point out of here as well, backspace, and then if I click set, what you'll see is it leaves that color of red and lime in place, set, and now when I go back to that device or this box and open up the extension again, you're going to see that there's no point associated with it, but I also have my parameters still in place. So what I can do is I can basically duplicate this. Oops, it looks like the computer's slowing a little bit.
Maybe for you close this window, Sean. I was just waiting for you to close that window.
Gotcha. So what you can do now is, since you have this point, or I should say this device templatized, if that's such a word, is you can actually just store this outside of the fence or put this into a different file if you like. And then that way you can come back, you can duplicate this, drag it to wherever you need to on your one line, go in quickly, open up your extension. Don't have to do these binary parameters, but you simply pick the appropriate 52A point that represents and then go from there and reuse it. Once you have that point there and it's correctly associated with your red and green, now you're going to get those true indications. If you forget to, you're either going to get, again, this yellow, or you're going to get that purple indication showing you that there is a configuration error, and that way you avoid false indications, but you still get the templates and are able to reduce your amount of rework each and every time.
One thing I'll add to that, Sean, is going to be, it'll be a shame not to talk about the second. I mentioned it earlier, but absolutely not to show it. So I'm going to show you guys this second extension. So earlier we were working under the HMI extension, but I also want to show you guys what's in the HMI library and templates. We won't use it in this application, but I want to make sure you guys show you what's available there. So if you open up that extension, what you'll see is a library of objects, tags, symbols that you could use. And again, just like what Sean was saying, that's just another way of kind of creating your own template objects, I guess you could say. But there's also these objects that are available that are really designed to be templates for you as well. So again, they're faceplates, things like that, where all you would do if you just pick one of these objects or faceplates is go and use the HMI extension. It'll let you pick exactly which button you want to configure and with what status. So I did want to make sure we showed you this window. I think Sean, we did the HMI Power Hour that we've done. I think it goes extensively into that as well, I think.
Yeah, I think I've done a few that had the various HMI tips and tricks, and I think we've got 3 or 4 previous Power Hours that had different sections on this.
Okay, I think so too. Was there anything else we wanted to touch on before we wrap up?
No, I think that's it. We've got a few questions still in the queue, so apologize to those who we didn't get to live, but we will definitely be sending out a Q&A form along with the recording of this session in a follow-up email. So we'll definitely get to you guys then. And then, as I'm sure, yep, okay, we're on that slide now. We do have the new customer portal. So again, this is for the power.novatechautomation.com. If you browse to that site, for those of you who do not have an account, you go ahead and request one there. It is a manual approval process on our side done by Jeremy Anderson, so he'll get to that hopefully within a day or two on that. And once you have access to that, you're actually able to browse through all of our previous Power Hour recordings, as well as find things such as documentation, firmware, downloads, again, the support community itself, and so on.
Did want to mention we do have a sales engineering booking site, so if you need just a little bit of time to talk with Sean or Johannes or Jeremy or Chi or Carlos or jump on that booking.novatechautomation.com site and see if we could book some time there. Aside from that, that's all we have. Thank you so much for spending the couple hours with us this morning.
Yeah, really appreciate you guys staying on for the whole Power 2 hours. So I know it's a long stint, but we really do appreciate you guys. And again, if you guys have any other questions, please, as Eob said, get a hold of us through the sales engineer booking I've told a few people along here to do so, and we'd be happy to go into any detail you guys like.
All right. Have a great day. Thank you, everyone.
Thank you.